This woman slowed down light to 17 meters per second, stopped it completely, and manipulated it.
She stopped light cold using atoms and lasers in her Harvard lab. Light or photons cannot travel faster than 299,791, 819 kilometers sec.
She and her team slowed down light by 20 million times, making it move at just 38 miles an hour. They achieved this by shining a light beam through a tiny cloud of atoms that were cooled to incredibly low temperatures, much colder than the empty space between stars. The cloud of atoms was held in place by magnets inside a chamber with almost no air, far emptier than the air in the room you're in right now. When atoms get extremely cold, a few millionths of a degree above absolute zero, they lose their identities and blend. At low enough temperatures, a collection of millions of atoms can behave like a single superatom. This collection is known as the Bose-Einstein condensate.
Howe and her co-workers finally cooled atoms enough to form a Bose-Einstein condensate.
They were among the first people in the world to see those condensates. She explained that scientists made a special substance called a condensate. They used lasers to change it, making it slow down light passing through. They suspended the condensate in a vacuum and shot laser pulses through it. The pulses slowed down and even stopped completely. When they turned the lasers back on, the light pulses returned. This means they can store light for a short time, like pausing a video. Using a special device she built, which looks like a big pinball machine with mirrors and lasers, she took a bunch of sodium atoms and cooled them to just above absolute zero. Then, she shot a beam of light into these sodium atoms, and amazingly, the light stopped. The light paused inside the sodium atoms. This happened because at the moment the light hit the sodium, it was also hit by another laser called a coupling laser. This might sound complicated, but it has a useful computer application. If you can control, stop, and manipulate light, you could create a new type of super-fast computer called a quantum computer. Instead of storing information on a disk, these quantum computers would use light to store and send information through optical fibers. Basically, when light is stopped, it does disappear for a moment. It gets stuck. You can make it move again by, in a way, opening a gate to stop the light. A special laser has to mix with a cloud of sodium atoms. The laser hits the sodium atoms, stopping the light. When the laser is turned off, the light starts moving again. A study published that says light completely stopped for a record-breaking minute. Dr. Lena Howe was asked, "Are you changing reality? Are you taking this basic fundamental property of all reality, light, and obliterating what exists in existing light?" She said what they are doing is a kind of magic, but on the other hand, it needs to be understood that we are dealing with very, very tiny quantities of light. It's not as if this can be extrapolated to mean that the light flowing off a person's face or off a tree could ultimately be captured or stopped, almost like some kind of science fiction manipulation of light. This is a very limited control of light involving this super-cooled sodium that eventually may have implications for super-fast computers. Dr. Howe said that she not only stopped the light but also moved it around, manipulating it for half a minute before making it reappear. We can hold on to the light, move it around, or even save it for later. We can actually manipulate it. With a coupling laser, Dr. Howe shone a beam of light, a light wave, through the Bose-Einstein condensate. The cold environment of the condensate not only slows down the light, but also compresses it. Coupling laser light is special because it couples together two energy levels of the molecule to make a superposition. Inside the condensate, the light from the coupling laser is compressed from being 1 kilometer long to only 0.02 millimeters. Once the light wave is inside the Bose-Einstein condensate, we turn off the laser. Though the light is gone, it leaves a distinct imprint behind in the atom cloud. This process creates a sort of cast of light in the actual matter, an imprint. Using such an imprint, Dr. Howe had shown that it is possible to save the light wave and even move it around for up to half a minute. This also means moving it out of the condensate where it was created. We can slow the light down, stop it, and move it around, and then create a copy of it in a new place, explained Dr. Howe. It is possible to manipulate the cast of the light, said Dr. Howe. We can make changes to the cast of light, which will then become apparent when we make it into light again. So it's not just a way to store light, but also to manipulate it. How can you manipulate the light wave? Could you, for example, change the color of the light? In principle, you could change the color of the light, yes. But for information processing, it's probably more important to change the shape of the light pulse so you get a different amplitude variation or a different phase. The aim has been fundamental research, that is, learning new things about nature. In the long term, I think, we might be able to use it for areas such as information processing in both areas of classical information and quantum information. The manipulation and storing of light could prove to be a step towards the development of quantum computers.
We all know that quantum computers exist.
The list of laboratories with functioning quantum systems includes
IBM, Google, Microsoft, D-Wave, Quera, and scores more.
There are several functioning quantum computers in both Europe and China.